So here's what I think his plan was, although he's never expressed it this way to me. So his end goal was to fly in space. So what do you have to do to fly in space? Well, you got to get a PhD in something. You got to learn to fly an airplane, you get a lot of hours behind you. You need to become a really remarkable scientist. And then you apply to NASA. And it took him 3 times. Third time was a charm. But, you know, this is the way Pierre's brain is organized here. And this is the way he began thinking about Boreas. This is basically a picture of the model. And this is the way he thought about Fife. And this is the way he thought about Izzleskip, which is what I'm going to talk about. Izzleskip initiatives. This Izzleskip initiative was the idea that if you're going to run Pierre's model or any other model, you've got to have the data to do it. It has to be in a common format. You can't have missing pieces if you're going to do global. You got to know where the land is. You got to know where the water is. And you got to put all that together. And if you want to go beyond what your own desire is for testing your own model, you've got to make this available to the community. And so with that idea in mind and that model in mind, Pierre's organized this first idea of getting a bunch of people together who had access to all these data sets, putting global data sets, putting them together into a common format and making them available to the community so that anyone could test their models. And so he organized a meeting of 240 scientists in 1992 to come together and, first of all, get the right scientists in the room who could define the requirements, but also get people in the room who had the data set. And so we organized organized all these breakouts and workshops so people could go off and think. And kind of a funny story about this was we had several breakout rooms at the Columbia Inn. And so as it turned out, people signed up for what workshop they wanted to go to, what breakout room. Well, Ann Henderson Sellers was running one workshop, no relation to Pierre's. And we found out that Ann Henderson Sellers' workshop was going to be relatively small. And so Pierre's announced during the break that we're going to switch rooms. And without having consulted with Ann. And so Ann just came out of her seat, berating Pierre's for having made such a unilateral decision on his own. And finally, in the midst of that, Pierre said, "Okay, Ann, you can have just stay with your room. I haven't had my rabies shot." So that ended that discussion. But what came out of that meeting in 1992 is the Izzleskip Initiative 1. And here you see all the data sets that were necessary. This is the publication that was published in BAMS in 1996. It described all of these data sets, and all those data sets were placed on CD-ROMs. By the way, you know, CD-ROMs, that technology is already antiquated. So no more CD-ROMs. You can still use them, but who uses CD-ROMs anymore? Grouped under some very logical headings, and the data sets covered 2 years, 1987 and 1988, 1 by 1 degree equal angle grid, monthly. Many of the surface meteorological data were available 6 hourly, and as well as monthly means. These data are stored were not only stored on CD-ROMs. As you can see from this slide, these data also now appear in the British Centre for Environmental Data Analysis, and so they're also available online. And as well, I think they're online in other places as well. One of the things we wanted to do as a part of that workshop was assess the status of the remote sensing algorithms. So we had model needs. We had a model structure outline, but in many cases we didn't have the data. So John Townsend and I and Ed and is it Tom? Was it Ted? Yes, the old memory goes slowly. Ted did the, and John and I did. John did land cover, and I did biophysical algorithms. So how do you get the species? How do you get soil moisture? How do you get all of the FPAR and stuff that Piers needed in his model? Well, while we're assessing all of this, Piers goes off on his own. So this guy also has, Piers also has a capacity to take a complicated situation and make it simple. So while we were thinking about how the hell are you going to process all this complicated data to get FPAR and NDVI and leaf area, how are we going to do all that? Piers is off taking the simple approach, taking the NDVI data, doing a little smoothing on it to get rid of the noisy part of it, doing a little solar zenith angle correction because VHR doesn't take data at the same sun angle all the time. If you get into the boreal forest, you got problems in snow, so you have to do something to adjust the signature to what you know it's going to be. In the tropical forest, you know you got a pretty flat NDVI, and if you see bumps and lumps, you get rid of them. And then convert NDVI to FPAR, just using a couple of simple approaches. One is assume for certain canopies it's linear, and for continuous canopies and for discontinuous canopies assume it's a little bit exponential. Then how you're going to calibrate it? Well, you look at the whole distribution of NDVI across. You throw out the bottom, you throw out the top. You assume that the top has an FPAR of 1 and the bottom FPAR of 0. So now you've got it calibrated without any kind of calibration. And you produce things like this with NDVI, FPAR, snow-free albedo, surface roughness. And then you go further. You take FPAR and you get LAI. From LAI you get reflectance and albedo. From LAI you get aerodynamic properties. And then you get photosynthesis and transpiration. So you get all of this stuff in a simple way using this really simple ideas. And the question is, did it really make sense? Well, when you look at the data, it's amazing. This is phaser NDVI. Over several years, I thought it was. Let me go back there. Try that again. I thought I had this several years. I guess it's just 1 year. But yeah, it works great. And now you've got a whole data set to put into your model, wherever you are, and you can calculate all this stuff. Well, Piers then left to become a satellite. And he left me with the initiative 2. It is take what he had done and reduce the resolution, go for 10 years, and oh, by the way, let's add in the carbon piece because the first piece was only the water. And so that's what we did. We got a whole bunch of people together. I mean, if you look at this, these people spent a lot of time putting these data sets together and attending meetings all over the world. And we put together a data set like Initiative 1, but it was for 10 years, better resolution, and it included carbon. And at all of these meetings we were holding, we got all the data providers in. So here are all the agencies that we involved who had the data, the data providers. So at these meetings, you had the data users. They would go off and discuss data requirements, and then the data providers would listen. The data providers would go away and say, how the hell are we going to give them that kind of data? But in the end, that data set was assembled, and it was put into the Oak Ridge DAC, and that is now also available online. And so here's some of the data we had. Basically had a lot of ancillary data, carbon data, hydrology, soils, near-surface meteorology, radiation clouds, snow, sea ice, we even all included socioeconomic data because socioeconomics was beginning to be a more important part of what we did, and also vegetation data. So we had many data sets now that are online, registered to a common grid, documented. Eric Browndick-Holston was the workhorse, and Paul Diermeyer did most of the work to put all of these data together. And then we published that data set in JGR Atmospheres 2006. We published, this is basically a description of the data. Then myself and Jeff and Jim Kolatz did an evaluation of phaser and GEMS. We compared the two by putting them into a carbon model and computing GPP and comparing the GPP to each other. And then other investigators like Alan looked at ERA 40 and the INSEP near surface meteorology. Then Paul Diermeyer did the kind of the soil wetness, soil moisture simulations. And this basically was then a really complete evaluation by Eric Ruth DeFries on the land cover data sets. So there's a lot of publications coming out of ISLSCIP. I Googled the things that cited ISLSCIP. I think there was, I don't know, all of these count. If they're not duplicates, I didn't want to go through and sort of them. There were 21,000 citations citing ISLSCIP 2. Here's just some of the ones that I pulled off. So you can kind of take a look at all of these different citations. Basically, a lot of model intercomparisons, a lot of global runoff studies, a lot of global forest cover studies, a lot of global fire emission studies, and a whole lot of carbon modeling papers have relied on these data sets. And you've seen this before. It's my last slide. I'll just summarize it by saying that those data sets continue to be used today. I wish I'd had more time to really dig into this to find out exactly how they're being used and how many citations we have. But Don Strebel and company lay the way for putting these data sets together and making them available to the community. So I was very happy to be a part of this, and that's about all I have to say.